vintage radio item with little known facts or lore. Radios using the triple triode Emerson Multivalve vacuum tube. The tube is called the Emerson Multivalve, not to be confused with the Emerson Radio and Phonograph Company, and was only made for a couple of years around 1926-27 by the Cleartron Vacuum Tube Company under the Emerson Radval Corporation name, whose premises was back-to-back with Clap Eastham Radio Factory in New York City. The proclaimed advantages of the multivalve: can be used in any standard circuit, uses any standard tube socket, operates at 5 volts and 1/4 ampere, giving 10 weeks of operation from 4 number 6 dry cells or 400 hours per charge of a standard storage battery. Full-size 90-volt B battery will give 12 months of service. There are 3 filaments connected in series. The second and third grid and plate connections are brought to a flange on the Bakelite base molding. This advertisement shows the first radio I will talk about. My first introduction to radios using this tube was at an auction in June of 1975. The Standardine Multivalve, made 1926-27 by the Standard Radio Corporation, Worcester, Massachusetts, has a solid wood cabinet with a thin Bakelite front panel silk-screened in gold lacquer. I bought it and 4 other great radios, including a Federal 61, for $147.50. Cheap, even back then. And I had been out of a job since layoff on New Year's Eve, and I thought I was being crazy irresponsible. This is the best performing of the 3 multivalve receivers I own. The schematic on the next slide will explain why. Very nicely laid out. Looking at the bottom of the chassis, you might think that the circuit has been rewired with modern plastic insulated wiring. This is not the case. In this time period, there were a few New England and New York radio makers using this stranded wire wrapped with colored cotton and glazed with a tough varnish, rather difficult to strip cleanly. You might think that the audio transformers are modern replacements as well, but again you would be wrong. Multiple examples of this set contain the exact same transformers. Unlike other radios using the multivalve tube, the Standardine reflexes the first triode section, designated P2, for RF and audio amplification. There are 2 tuned circuits giving acceptable selectivity for daytime use. Audio output when used with an efficient horn speaker of the day is pretty good. It would, however, not be adequate to drive the new free-edge cone speakers coming into the market at that time. They were judged to be more mellow-sounding but much less power efficient. The back label was missing, but a collector, the late Bill Condon in Colorado, provided me with this photocopy that was very good for pre-1980 technology. I reciprocated by making a professional silkscreen of the front panel gold graphics. The results on the heavily worn front panel he provided to me were quite good. I still have that silkscreen and original art after 40+ years. My next receiver is a recreation of the so-called Lodge-In circuit, as shown in a folder distributed by the Precision Coil Company of New York City and featured in a Popular Radio article in the November 1927 issue. The circuit was frequently criticized. Its main claim is that although it employs regeneration, the energy coupled back into the antenna is minimal and will not materially interfere with local receivers if left in the oscillating condition. The circuit is not reflexed, and so the power required to feed a loudspeaker is provided with an additional transformer-coupled vacuum tube stage using the type UX112 that matches better to the lower impedance of cone speakers such as being shown used in this photo. Note that there is RC coupling between the first and second audio stages. This recreation was built by the late John Caperton of Louisville, Kentucky, sometime in the 1970s, and is a joy to behold. I cannot recall ever having tried to use this set, even though John said that it worked pretty well. The gold-painted Samson Transformer is a high turns ratio transformer connected from the detector to first audio. Note that the tuning capacitor has die-cast plates. Most of these capacitors are found to be unusable due to splits or severe warping. This one, however, is essentially perfect. Close inspection of the taper geometry of the plates reveal that this clever approach yields a straight-line frequency tuning experience in a more compact mechanical arrangement. The last of my three receivers that very well may be the only surviving example is the USMC 2-tube multiphone, made by the United States Multiphone Company, New York City, circa 1927. The front panel is gold ink silk-screened on colored bakelite with a tough varnished glaze, a quality panel production method. Unfortunately, poor storage conditions cause the varnish to turn foggy in places. There is no cure. Definitely a nice-looking set, though. Here again we see the multivalve tube used as a double-tuned RF amplifier, detector, and first audio amplifier, followed by a UX112 power amplifier tube. Here is the circuit. When I first saw this radio in a collection, it was in brand new condition. The owner had no interest in trading it away. Unfortunately, it went into a storage building infested with insects that gnawed into the wax transformer windings and broke many of the windings. I could not verify the turns ratio of these transformers. I did substitute, for purposes of testing, 1:3 ratio transformers so that I could operate the set. It tunes as well as the standardine, but does not provide nearly as much volume, even with the power tube. It could be that the detector to first audio transformer had a higher turns ratio, although they appear to be the same construction. There are a few unusual construction methods in the multiphone. The chassis is wired with 18-gauge stranded wire with extruded black rubber insulation. There is a termination method I cannot recall having ever seen in any other receiver. The wire is cut to length, and then a awl was used to punch through the wire insulation and hopefully pass through the middle of the wire strands without breaking them. An eyelet was inserted into the hole and then crimped to form a termination. There is a mystery component that is placed where you would expect the detector grid coupling capacitor to be located, with a usual 2 megohm resistor shunting the capacity. It is wrapped in a paper label and identified as a multiformer. It bears the ominous warning, "Caution, breaking this seal voids factory guarantee, USMC." I cannot X-ray this part and can only report that it appears to be a low-value capacitor with perhaps some sort of carbon rod resistor in series with the capacitor. I can think of no such advantage to the usual part. The cabinet is certainly going to raise eyebrows with some collectors and historians. It is easily recognized as that used on the Atwater Kent Model 20 compact receiver. True enough, these cabinets were made by outside contractors to Atwater Kent specifications. Some may know that especially during 1925, manufacturers were expecting the already booming consumer radio market to reach even higher levels, and by late in the year were accumulating great stores of parts just as the boom started to stall. Lots of parts wound up being dumped on the market in the mini recession that hit the country in 1926-27. This was true of these cabinets. They could be had for as low as $2.50, according to wholesale distributor flyers I have seen. USMC only needed to insert a wooden plug into one hole and then bore a new hole for the battery cable to exit the top of the chassis. It made for a handsome set. I have known about the baby Emerson radio using the multivalve tube for many years, but the two I have seen for sale have been priced way above my budget. This outfit seems to have been made in at least 3 production runs. This one pictured may be the last version since it is a photoresist etched metal panel. The advertisement has a tie-in to Fried Eismann Radio Company, but there is also a version with a thin Bakelite front panel silk-screened with different but similar graphics, but says Clap-Easton Company, Brooklyn, New York, and also says licensed under Armstrong patent, implying that this set has a regenerative detector. This version uses a small rheostat in series with the regeneration coil, but one cannibalized example with a Bakelite panel has a small value compression capacitor in place of the rheostat. I think the various versions of this set could have been in part because the maker was playing fast and loose about the patent license and associations with Clap-Easton. Note that the advertisement is offering a package deal including a small horn speaker. It definitely has an Amplion driver and a papier-mâché horn finished in green with a splatter overcoat of black paint. I would love to get a flatbed scan of this image. I could make a near-perfect recreation using Photoshop. Radio News for February 1927 features a construction article of a Haynes DX2 multivalve receiver, a RF amplifier, regenerative detector, and first audio with an additional UX112 used as a power amplifier. It makes use of the elegant Hammerlin autocouple that does a good job of maintaining maximum tune circuit efficiency across the broadcast band from 500 to 1500 kilohertz without the likelihood of breaking into oscillation. I do not think this circuit was ever incorporated into a branded receiver or complete box set of parts. Another popular radio article presents another circuit arrangement named the Univalve. Ray Bentliff, in his 1997 article for Antique Radio Classifieds, mentions others, but I can find no recent references to those sets mentioned. To be fair, the Emerson triple triode multivalve was not a unique tube design for the 1920s. Companies in Germany and the United Kingdom had similar ideas at the same time. Let me tell you something of these other tubes and the receivers that use them. A German company with the brand name TechID made at least one triple triode, the VT139, that found its use for a couple of years around 1928 in the Brandt Model D3 receiver. It begins with a circuit built into the wood box as shown here, and eventually is built into a custom-molded Bakelite box. The tube and tuning coils are still externally mounted. The same receiver may have been marketed under one or two other brand names. Radio Amato makes a very similar receiver, the Model 3033. Fernfunk makes a similar style radio using a double triode version, the VT126, but apparently they are made in much smaller quantities. One British collector has this British Thompson Houston receiver, the Model VR3 Form CA, that a radiomuseum.org listing places as a 1927 model. But there is a Wireless World advertisement from September 1928 announcing their new product range, and it shows this receiver. It uses this Mazda TS215 double triode. The receiver appears to be very rare in collections. Keith Geddes and Gordon Bussey, in their book, The Set Makers, say that BTH merged with Metrovic in the autumn of 1928, but soon withdrew from the receiver manufacturing business altogether. So this was essentially a stillborn product line. This British-made vacuum tube is shown in a February 1929 issue of Wireless World. It appears to be very rare in collections today. There are two filaments in series with a rating of 1.8 volts. They pass through two grid plate triode assemblies. There is a duplicate string of filaments to serve the other two triodes. This probably results in very little power availability to drive a cone-type loudspeaker that was in common use by that time. Also, having the tube elements so close together probably made for parasitic coupling between the stages. Also, by that time, the screen grid tetrode would have provided much greater RF performance. In 1928-29, there was a huge interest in portable receivers in Great Britain. They probably envisioned it for use in such compact receivers. This series of multivalve sets were contemporary to the introduction in Germany of the Lowe OE333 with its famous 3NF tube, having a detector and two stages of RC-coupled triode amplification contained within a single glass envelope. In the mid-1920s, D.S. Lowe was trying to develop triode amplifiers with maximum possible amplification using resistance capacitive coupling. It required the use of very high-value resistors and resulted in very low currents, so low that parasitic capacitive coupling and wire inductance became limiting factors. His genius was to place these resistors within the vacuum envelope along with the triode assemblies, drastically reducing those limiting factors. This was the genesis of his design. Many have incorrectly stated that the Louisville Multivalve was developed as a way of getting around the taxation formulas used in Germany for the sale of broadcast receivers. Rather, it was a happy coincidence. It was true that part of the taxation formula did factor the number of tubes employed, so it did also allow him to take advantage of the rules and offer a lower-priced radio. About 1 million radios of various iterations were made from 1927 to 1933 and are worthy of their own story.